Hi everyone, today I wanted to share with you something mathematical related that I found out today, and I think it's pretty amazing. Now let me draw it out for you. So today I was in chemistry class, right, and I was getting a bit bored, so I just started doodling. I started doodling something that quite a few people doodle. The thing is, you put a bunch of dots on a piece of paper, and you draw lines to connect each and every one. So you can draw 5 dots. I just go like that. And those are the outside ones, the inside ones also have to be connected like so. And like this, every dot is in connection with every other dot through means of a line. These are 5 dots, and to connect all of these, it would take me 10 lines. We could do a bit less, if we have 4, let's say we have 4 lines. We can align them like this. This is 1 line, 2, 3, 4, 5, and 6. These are 6 lines. For 3, we would have 3 dots. We would only need 3 lines to connect every dot with every other dot. The larger the number of dots, the more amazing shapes you'll get. The shapes will gradually increase in size and number of lines. So let's do a slightly bigger one. Say for instance 7. 1, 2, 3, 4, 5, 6, 7 dots. We connect all of these. First we do the outside lines. It's 1, 2, 3, 4, 5, 6, and 7. 7 lines. Let's connect all the other ones. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21. So these are 21 lines. And, you could go on and so forth, and I did actually all of them up to 12, and you can put all of these in a table. Let's draw a table here, and call this dots, D. We'll call this lines, L. And for 0 dots you have 0 lines. For 1 dot you have also 0 lines. For 2 dots you have 1 line, as is evident through here. For 3 lines 3. For 4 lines 6. For 5 10. For 6 15. And for 7 21. Now, why are these numbers so interesting? I'll tell you the following, because there's a certain pattern it follows. It's kind of hard to explain, but just let me show you what I mean. Let's start with 0. With 0 dots I have 0 lines. If we go to 1 line, 1 dot, I still have 0 lines, so that is plus 0. If I go from 1 dot to 2 lines, I go from 0 to 1, which is added plus 1. If I go from 2 to 3, it changes from 1 to 3, which is plus 2. And this pattern is continued. If I go from 3 to 6, it's plus 3, according to the previous value. From 6 to 10, it's plus 4. From 10 to 15, it's plus 5. From 15 to 21, it's plus 6. From 21 to 28, it's plus 7. Another thing I noticed when writing these values down is that every other number is a multiplication of itself and a whole number. The next whole number. Let me show you what I mean. For 1 dot, I have 0 lines. 0 is equal to 1 times 0. For 3 dots, I have 3 lines. 3 is equal to 3 times 1. When I have 5, 5 is equal to 10 lines. 10 is also equal to 5 times 2. When I have 21, when I have 7 dots, I have 21 lines. 21 is equal to 7 times 3. Same thing for 36, which is equal to 9 times 4. And 55, which is equal to 11 times 5. And so on and so forth. And after I found out that these are multiplication of whole numbers, I actually found out that these whole numbers are actually used by an increment of 0.5 for every step of dots that you take. For example, if I take 1, this is, well, for 2 dots I have 1 line, and 1 is actually equal to 2 times 0.5. And this trend also continues. If I have 4 dots, I have 6 lines. 6 is equal to 4 times 1.5. So for every step you take, you have to multiply the amount of dots by 0.5 times the number of dots minus 1. If you plot this in a graph, you get this graph, a parabola, which means that it's a quadratic formula, which is also supported by the fact that the formula to derive the amount of lines from the amount of dots, L equals D times 0.5 times D minus 1, this would also be in brackets, then you have a quadratic formula. And what this means is that the amount of lines needed to connect every dot to every other dot to a certain number of dots is a quadratic formula. And I'm not sure what the significance of these findings are, but it was pretty cool to find out myself, with a little help from my best friend Joey. And there you have it. Think about it, maybe you'll solve some kind of giant mathematical problem. This is Morgan Phillips. Thanks for watching.